Hi kiddos, welcome back. How was your time off from school? So during this quarantine, I've been at my mom's, and as you guys know, this is Lexi, or in other words, Stinky Beans. And this guy here is Max. And now what I'm holding here is a very special birthday cake. So whose birthday was it? It was, in fact, Max's birthday on April 15th. And today, actually, April 20th, is Lexi's birthday. So we celebrated with this little cake. Do you want to know how old they are? Lexi, today, turns 4. Can't believe my little baby's all grown up. And Max, our little old man, just turned 10. So I have this funny video that I want to share with you guys of Lexi and Max. I'm going to show you. Oh, there's me. Hey. I'm going to show you from my phone because I couldn't figure out how to get it on here. I know, I'm old. Okay, here's the video. So there's Lexi being insane. And there's Max. And there she is. She's crazy. And let's just rewind back to Max's face. So, next time you guys are being crazy, just think of me and think about how that's how I look at you when you're being wild. All right. So, is there anyone who also has a Max face? All right. Enough messing around, Miss Mish. Let's get to the business. All right. So let's recap. So, before break, we talked about systems of equations. So what is a system of equations? It's when we put more than one line together. Okay, and we can put them together on a table and solve them that way. We can also solve them graphically. And then we also looked at them algebraically. Gosh, it's been so long I forgot how to spell. All right, so let's take a look now. Okay, so we have these 3 ways of solving, all right? How do I identify a solution there? So when I make a table, I look for the point of intersection. Remember, that's really what my solution is. It's where the 2 graphs cross. So when 2 coordinates on the table, we're looking for where they are the same. So if I look at my coordinates, I have -2, 4, 10. Those aren't the same. -1, 6, and 9. Those aren't the same. 0, 8, and 8. Oh, those are the same. So that must mean my solution, the solution to the system, is 0, 8. Okay. On a graph, we're also looking for the point of intersection. But that means something different. I mean, it looks different when it's on a graph. All right, that's where the 2 lines crisscross. So here, I should see them cross, and I do. And that coordinate is 0, 8. So again, the solution is 0, 8. All right, and then lastly, we solved it mathematically for x and y using our solving square. That's the algebraic way. All right, and just to save time, I showed you the steps there. And when we do that, we see our solutions written a little bit differently. We get some x equals and some y equals. But remember, all of that means is that this is a coordinate, and we can write our coordinate with x first, then y. So again, our solution is 0, 8. Okay, so that's what we did before break. All right, so what you should remember from that is that no matter which way I solve, so whether I do it from a table, I got the solution with 0, 8. The graph, I also got that as the solution. And then algebraically, I also got the solution. So no matter what way you solve, your solution is always going to be the same. And we write our solution as a coordinate, x comma y, or we say x is equal to some number and y is equal to some number. Okay? All right, so here's what's going to be new. How do we check a solution? All right, so it's really similar to back when we used to check for equivalence, but now we're just checking for a system. All right, so here's what we're going to do. We're going to plug in x and y into both equations. And we're going to check for equivalence. All right, so the important thing is here that we're checking for both equations, okay? So let's use the equations that we just did. Equation 1 was y equals 2x plus 8, and equation 2 was y equals negative 1x plus 8. Now the solution that we're checking is 0, 8. So that means my x is 0. So in both equations, I need to put x for 0 there. And my y is 8. So wherever I see a y, I'm going to put 8. Everything else stays the same. Okay, and now we're going to check for equivalence. So if I look here, I'm going to draw my dotted line. Is there anything to simplify on my left side? No, so I'm just going to bring down my 8. On my right side, I can simplify that. So when I type that into my calculator, I get 8. Are they equivalent? Yes. So that means this first equation works. Now I do my second equation. I check my left side, simplify, bring it down. I check my right side, I plug that in the calculator, I bring it down. Are they equal or equivalent? Yes. Okay, so this means, so when they're both equal, that means 0, 8 is a solution. All right, let's keep practicing. All right, so what you're going to do after this video is you're going to practice IXL. So what I just did was I just set up my paper to practice some IXL questions so you can see what it's going to look like. So here's our first question. Is 1, 9 a solution to the system of equations? Let's see. So I have equation 1, 6x plus 3, and equation 2, x plus 8. I take my point, this is my x, and this is my y. All right, so let's plug them into our equations. X is 1, x is 1. Y is 9, y is 9. Everything else I bring down. Okay, now let's simplify. I simplify my left side. There's nothing else to add it to, so I just bring it down. Right side, I'm going to put in my calculator. I get 9. So is this equivalent? Yes. Let's check this side. 9. My right side, 1 plus 8. That's also 9. Are they equivalent? Yes. So we go back to this question. Is 1, 9 a solution to the system of equations? If this works and this works, that means yes, it is a solution. All right, let's look at number 2. All right, so I have equation 1 and equation 2. I'm going to keep my colors the same. So 17x plus 17y equals 18. X plus 6y equals 12. Notice how they look a little different than the other ones, but that's okay. I still have some x, and that's going to go wherever I see an x. So what number am I putting in these parentheses? 6. All right. Now, my other number comes from this y. So wherever I see a y, I'm also going to replace it. What am I replacing this with? The 1. Everything else gets brought down. All right, now we check for equivalence. So I plug that in my calculator, and I'm going to bring this down. All right, so when I plug this in my calculator, I got 119. Is 119 equal to 18? Does that make sense? Nope. So I put an X. Let's do this equation. I get this. I get 12 on this side. And this just gets brought down. I also get 12. Does that one work? Yes. So now the question again, is this a solution to the system? So in order for it to be a solution, both equations have to work. And we see here that this one did work, but this one did not. So this means that this is not a solution. So remember, they both have to work. Okay, last one, I promise I'm almost done. Let's check one more. So I have equation 1 and equation 2. Equation 1 and equation 2. All right, let's identify my x. So wherever I see an x, I'm going to replace it with a number. What number am I going to put there? Okay, now I'm going to do the same thing with my y. Okay, everything else gets brought down. Okay, now we simplify. If this is the only number on that side, I'm just going to bring it down. This side, I'm going to put together. 2 plus 5, that gets me 7. Let's do equation 2. 9. 4 times 2 plus 1, that also equals 9. So, does 9 equal 7? Are those equivalent? Nope. Does 9 equal 9? Are those equivalent? Yes. Now we go back to the question. Is this a solution to the system? No. It is not a solution. But why? Okay, Let's remember, in order to be a solution, both of these have to work. And in this situation, it works for equation 2, but it does not work for equation 1. Therefore, it is not a solution. All right, guys. So now what you're going to do is you're going to go to IXL and you're going to test this out. We are fully in Algebra 1 now, so it is your time to shine. All right? As always, if you have any questions, type them in at the end of the video.